In this video, we're going to see how you can use Fiddler Everywhere to evaluate the web performance techniques for a site. So I'm often asked to look at a website and give an opinion on what might improve its performance. And the first thing I like to do is open Fiddler and take a look at various pieces of it where I can see whether or not they're using specific techniques. So we'll go over what the techniques are and how you can tell if the site is using them using Fiddler Everywhere. To do that, we're going to look at our travel page again, and I've got a before and after version. So the before is just an easy implementation using Bootstrap, not a lot of thought put into performance at all. The second one is using a lot of the techniques we're going to talk about during this talk. So we'll just see that they look visually the same. So this is the before version, and if I click on the after, you'll see that visually I have not lost any quality. It looks the same, but the performance metrics are much better on this than the one before. So we'll start to compare these two throughout this talk. So here we've got Fiddler Everywhere open. We've requested the performance before. The first thing we're going to look at, we're going to select all the requests on the left-hand side, and we want to look at the Overview tab. So a couple things that are interesting. You can see that there were 13 requests made. And if you look at the body received, that's about 2.8 meg. So a pretty large size. That's a typical web page today is somewhere in that range, but usually that's 100 requests or so. And if I scroll down, it will give us more information about the sizes based on the type. So we can see here the image JPEGs are a good portion of the page weight. So we're going to focus on that and see in the after how that has been improved. But the overview gives us a quick feeling for how general performance for this is and where the size might be too large. We'll do the same thing with the after version. We'll just select the requests that were made. And looking at the overview, we see it was also 13 requests, but we can see now the body received, it's down to about 130K. So the entire size of that page and all of its resources are smaller than some of the single images were before. So we've made a vast improvement to the download time because the file and all the resources are much smaller. And again, if we scroll down by response size by type, you can see that JPEG is no longer the dominating size. In fact, it's smaller than the CSS and the JavaScript. So again, this gives us a quick view where we can spot check and see, does this fit in for normal metrics for pages, how many requests it's making, and a rough idea of size and what's causing those sizes. The first performance technique we're going to look at is whether the site is using HTTP compression. So with compression, if the browser signals with the accept encoding that it can handle compression, the server will compress the content, which for files like JavaScript, CSS, text-based files like that, they compress very well. So I selected the JQuery JavaScript file, and on the overview on the right-hand side, I'm looking under sizes, and it shows a body size of about 287K. So that's what it looks like. If it were compressed, it would mention compression there. So we'll look at that same file in the after site. Looking now at the after version, we'll notice a few things if we look at the jQuery. So first of all, I chose a jQuery library, the slim version, which made it automatically smaller than the original that we had. If we look on the right-hand side in the overview, you can see the body uncompressed. So it shows that the slim version was about 72K. You can see the body for this was about 31K. So using compression, we can see that it reduced the size by more than half. We just need to set a server setting saying we want to compress static content. Most modern websites do that automatically today, and this is how you can check whether your files are using compression or not. The next technique we're going to look for is expirations or caching. So if you notice here, Fiddler Everywhere shows me there's no caching sent back from the web server. So what that means is by default, someone comes and requests this page today. If they close their browser and come back tomorrow, they'll get the HTML, and even if nothing has changed, if they see all of these resources without specific caching directives, the browser's left to decide if it's fresh or not. So in other words, it looks at the content that's in the browser cache and makes a decision about whether it should use it or whether it should ask the server if it has been refreshed. So once the browser makes that decision, often it will send to the server and say, for instance, I have this jQuery file. has it been modified since this time, and they'll send what they have in their cache. Then server side will look and say, no, that hasn't been. It'll send back a 304 not modified. Well, the bad news is that round trip just to ask if it's been modified is sometimes expensive, especially if you're in a high latency network, which just means it takes a long time to send back and forth. So we want to use caching or expirations where we're specifically telling the browser, you can consider this content fresh for this time period. So we'll look at what this looks like in the after version. So now in the after version, you can see that there's nothing specifically set for the HTML. We want it to come back and ask for that each time in case something has been changed. But we specifically set how long this content can be considered fresh. So the max age is in seconds. So if you look at Bootstrap Min, that is good for a year. And if you look at the images, that happens to be 30 days. So now what you've done is instructed the browser the day it gets this, mark it to be considered fresh for this time period. Don't come back to the server and ask for it. So people often ask, if you do that, what would happen if you did have to change one of those files? You just need to make the URL different. So you can either use, people put things on the query string as an additional parameter, some way to indicate, you could put a version number into the actual file name itself. But by changing that, then the browser, even though it has a cached copy, if I called it bootstrap min.2.css or I tacked on a question mark, v equals for some sort of version, the browser will see that that's not already cached and go back to the server for it. So this saves a lot of back and forth, and it's going to pull all those resources off the local browser cache, which is much faster than talking to the server and getting things over again. So you want to set expirations or caching directives in your web server and specify the time periods you consider various types of content to be fresh. The next thing I'm going to check for is whether the site uses a CDN, a content delivery network. So the idea with a CDN is it's a service that has CDN servers much nearer my customers. So if someone were to come to my website, they need to visit the original site where I have that hosted, but I want it to pull all of the resources, the CSS, JavaScript, images, fonts. It'd be ideal if those were pulled from a server that's closer to them, so the network latency is a lot shorter. So what I'll do to spot check that, I will look first in the overview, and I happen to see that it's named CDN, so I notice that this is indeed using another host. So I can see that here just by the naming. I also like to look at the overview and check the number of hosts. So you can see the requests per host. So the idea is I don't want to have to create connections to a lot of different hosts. Even using HTTP2, it needs a different connection for each specific host. So I'm trading off here the connection time to access a CDN, but then being able to pull the files from that closer server. So I want to look at two things. Again, look to see if it's using a CDN, that there is at least another host. They often name them CDN. But also I look at the request per host. I don't want to have a whole lot of different hosts. Like I could have pulled JQuery from any number of sites that host that file. Instead, I choose to download the version I want and put it on my specific server, again, to avoid connections out to another host. And the same with fonts. So I'm using a Google font. I've chosen to host that inside. So I've greatly reduced. Now I only need connections open to 2 separate hosts. So those are both things you want to look at to improve your performance, is reducing the number of hosts and using a content delivery network. The next technique I'm searching for is whether the site uses what's called minified files. So if we look at this example, we have bootstrap.min.css. So often that's part of the actual name where they add the .min to indicate that this is a minified file. And the idea with minified files is you're removing the extra line breaks, often most of the comments, all of the new lines. So you're making it just a very compact version of that file. The good news is on the client, so I'm also using it for JQuery, it will minimize it, but through the use of either source maps, or if I want to use dev tools, you can do a pretty print. So it sends it to the client because most times your customers don't care what your CSS and JavaScript files look like. by minimizing them, it helps to minimize and compress them. You've greatly reduced the size of the download for those files. And again, if a developer needs to do client-side JavaScript debugging, it's possible to get back from the Minified version to the original so that you can still troubleshoot and walk through the source code on the client. So again, spot check by looking, is it called .min? And if we look on the inspector on the right, as we scroll down, you'll see that it's taken out all of the line breaks and the spacing and the tabbing and everything else to greatly reduce the size of that download. So there's lots of tools that will do this. We do this as part of our build process typically today. As you get ready to release, the build process will take those files, minimize, which greatly reduces the size and improves the performance. The next area we're going to focus on is the images. So we noticed in the before version that some of the sizes were rather large. I typically will sort by body size, and I can see that there's a lot of JPEGs at the top that are around 300K or so. After you've worked on sites for a while, you get a feeling for how big images should be based on how they look on the site and approximately what their size should be. So by knowing what my site looks like, I can tell that these are larger than I probably need. So you can use any common image editing tool that you like. I can open up those JPEGs. Often the tool will have a side-by-side version where I have the original and I can choose a compression factor for that image. So I'm trading off quality and size. And on JPEGs, it's pretty common that I can greatly reduce the size without impacting the image quality. So again, I can just pull that slider, look at the two of them and save. So we'll look at the before version of these images, and then we'll take a look now at the after. Now looking at the after version, we can also see the body size, but we notice our images were from about 300K, they're down to about 6K, which is a huge improvement. So that's where we got most of the size reductions with the before and after. We've taken each individual JPEG file and pulled up and did that quality trade-off. And again, if we were to compare the two, we can see that the quality is not diminished, but we've had a great reduction in the size. The next area to review is whether the site is using what's called responsive images. So a lot of sites use responsive design where it's set up to look good at various breakpoints. So on a phone, tablet, desktop, it uses the width of the device to determine how things should look. In this case, this is our desktop view of after, or our large breakpoint. And we can see there's a couple images at the bottom. I like to use the width of the image in the actual file name because it helps us when we look at things like this. So as I opened up the after site and scroll down, you'll see that on the large breakpoint, some of the images are 2048 for a width because that's what was needed to show them at that large breakpoint. We're going to now then look what it would look like coming from a smaller breakpoint device. I'm just going to use DevTools and device emulation to look like a phone, and we'll see how that looks in Fiddler for comparison. In the after version, when we're in the small breakpoint, if we look at the bottom, so it only needed the 1024 version to look good at that breakpoint for the width of the screen where it's going to be displayed. So I happen to use source set in this example, and image with a source set attribute. I just need to create images in a lot of various sizes, and using the source set, it's telling the client, you make the right choice. You know the size of the image that needs to be displayed, you know the pixel density of the device, so it's chosen different image widths based on the situation. So this is a good way to spot check and see, are they using responsive image techniques or not? Because especially on a small device, we don't want the huge image that we would use for a large breakpoint on a phone that might not have a great connection. That's the benefit of using responsive image techniques like source set or the picture element. The next technique we're going to look for is what's called lazy loading. So I like to emphasize the rendering of the main viewport, and I want to make that as fast as possible. I know there are other images that are lower on the page. I don't need those to load up front because that might slow down the initial rendering. Lazy loading is a technique where you say, I don't want these to load initially, but as the browser is scrolled, I want those images to be selected and downloaded. Here's the after version. Again, we're just looking at the top of the page. We'll see what the Fiddler requests look like. So this is what we've seen throughout the talk. I'm going to right-click on the last one and mark it in orange so we can remember where we were. If I go back to the browser, as I scroll down, these images are coming into view, and those are some of the larger images. We can see that there were additional requests for those images. Again, lazy loading just gives me the ability to say those don't need to be loaded initially, but only when you scroll down. There's various ways to do this. Today I use a JavaScript file called lazy sizes. This has also been added natively to some of the modern browsers using the loading attribute. So either way works. The loading attribute is not supported for all of the clients, so I continue to use the JavaScript, but I just need to indicate on the image that I don't want you to load right away, and then the browser or the JavaScript will take care of when it's about to come into view. It will automatically download that particular image. So again, I'm emphasizing the main rendering of the page. It's possible that the person may not even scroll down, so why download those unless they need them? That's what lazy loading lets me do. Another thing to look for is the version of TLS that's being used for HTTPS. So you should be using HTTPS for all of your websites. TLS is the actual encrypted tunnel that's used. There are various versions of that. The most recent is TLS 1.3. The advantage of 1.3 is it uses less handshakes at the beginning. So instead of in the world of TLS 1.2, it needs to go back and forth 2 times to set up the TLS. It only needs to do that once. I've worked on a site where going to TLS 1.3 was 20% faster. So just setting a newer version of TLS that's supported by most modern browsers, you get, first of all, better security, but there's that less handshake also helps in the connection creation, and you could see some performance benefits. The way you can tell the version, here I clicked on the HTML page, and in the overall and the request details, you can see that it lists the version of TLS. In this case, it's 1.2, but that's where you can check, and if you're able, TLS 1.3 will be more secure and should perform better for you as well. The last thing we're going to check in this video is whether the site uses HTTP2 or not. A great new addition to Fiddler Everywhere is the ability to use HTTP2 as a protocol. I first need to make sure that I have it configured. Presently it's still a beta feature. I'm going to go into the settings, go to connections. So in settings, in connection, I'm going to enable HTTP2 support. In Fiddler Everywhere, I've added the column for HTTP version, and we can see that it's using HTTP2. The advantage of HTTP2 is it will only use a single connection to each host. So in the past, when browsers wanted to connect with HTTP 1.1, the spec said they could open 2 connections per host. Eventually, browser vendors found they could do more things in parallel, and most of them were opening up 6 separate connections to each host. Each TCP TLS connection needs to do some handshakes to be set up, and they start slow. We don't want to go through that multiple times if that's not necessary. So HTTP2 did away with that and said it's going to use 1 single connection per host. It just multiplexes the requests and responses on that same connection. This is just how I can tell if that site supported HTTP2 or not, which brings along some performance benefits as we talked about with connections. It's nice that Fiddler Everywhere now supports HTTP2 and that we can see that that's how this site was requested. Throughout this video, we've seen a number of performance techniques. We did not dive into how to configure all of those, but we were focusing on how Fiddler Everywhere allows me to look at a particular site and look for certain techniques to make sure those are in place so that we have the best performance we can expect for the site. In the next video, we're going to look at how we can troubleshoot for other devices. So I run Fiddler Everywhere on my laptop, but I may want to see traffic from phones, tablets, or even potentially another laptop where I don't want to install anything on their machine. So we'll look at how we can configure Fiddler Everywhere to accept those requests, and how we can configure a client to point to our instance of Fiddler Everywhere so we can do the tracing. We'll also see how we can export the HTTPS certificate so that can be used on the client so that we can decrypt the HTTPS traffic.